Graphs and periodicity. Welcome to the fascinating world of graphs and periodicity, the visual rhythm behind trigonometric functions. In this lesson, we'll explore how sine, cosine, tangent, and their reciprocals, cot, sec, and cosec, dance across the coordinate plane with perfect mathematical harmony. Let's begin by understanding how each function behaves, how its graph looks, and how periodicity brings predictability to their curves. Graph of sin x. First, the sine function, the smooth, wave-like motion that starts at 0. As x increases from minus 180 degree to plus 180 degree, sin x rises gently to plus 1, falls back through 0 to minus 1, and then returns again to the origin. Notice how the sine curve is continuous, smooth, and periodic, repeating every 360 degree. Its maximum value is plus 1, its minimum minus 1, and it always passes through the origin. This elegant shape makes sine the foundation of all periodic motion, from sound waves to alternating current. Graph of cos x. Next, the cosine curve, a sibling of sine but shifted. When x is equals to 0 degree, cos x is equals to 1, giving the graph its peak at the origin itself. As x increases, cosine decreases to 0 at 90 degree, dips to minus 1 at 180 degree, and rises again, creating a mirror-smooth oscillation about the x-axis. Like sine, the cosine function is periodic, repeating every 360 degree with the same amplitude of plus minus 1. Sine and cosine together form the heartbeat of trigonometric graphs. Graph of tan x. Now let's move to the tangent function, the curve that never stays calm. As x approaches 90 degree, tan x shoots towards infinity, creating a vertical asymptote. Between minus 90 degree and plus 90 degree, the curve passes through the origin and stretches infinitely in both directions. Unlike sine or cosine, tangent repeats every 180 degree, showing its own type of periodicity, sharper and more abrupt. Its pattern helps us identify undefined values and regions of rapid change. Graph of cot x. Cotangent is the reciprocal of tangent, so its behavior flips. Where tan x tends to infinity, cot x tends to 0. You'll notice its curve descending between asymptotes with undefined points where sine is 0. Like tan x, cot x repeats every 180 degree, but its direction of rise and fall is reversed. Graph of sec x. Secant, the reciprocal of cosine, gives us a distinctive U, shaped and inverted. U-shaped pattern. Wherever cos x is equals to 0, sec x becomes undefined, producing vertical asymptotes. Between these points, the graph opens outward, never crossing between minus 1 and plus 1. In fact, sec x exists only outside that range. This helps us visualize the infinite nature of reciprocals in trigonometric domains. Graph of cosec x. Finally, let's observe the graph of cosecant, the reciprocal of sine. Similar to secx, its graph alternates between upward and downward arches. Since sine ranges only between minus 1 and plus 1, its reciprocal cosec x never lies between those values. That's why you'll notice blank regions around the x-axis, places where the curve simply cannot exist. Composite graphs and periodicity. Now that we've seen them individually, let's look at how these graphs interact. When plotted together, say y is equals to sin x and y is equals to cos x in the interval from 0 degree to 180 degree, you'll notice the two curves intersect at 45 degree, forming beautiful enclosed regions. This intersection helps us solve equations, visualize trigonometric identities, and understand oscillatory motion. Every function repeats itself in a fixed pattern, and that repetition defines its periodicity. For sine and cosine, the period is 360 degree. For tangent and cotangent, 180 degree. And for secant and cosecant, again 360 degree. Application and visualization. Understanding these graphs is more than an academic exercise. Engineers, physicists, and data scientists all rely on these curves to model waves, signals, and circular motion. Every peak, trough, and asymptote tells a story about real-world behavior, from how light oscillates to how tides rise and fall. So the next time you see a wave on a graph, remember, it's not just a line. It's the geometry of rhythm and motion. The trigonometric functions, sine, cosine, tangent, and their reciprocals are more than formulas. They're nature's blueprint for periodicity. Thank you for joining this journey through the graphs and periodicity of trigonometric functions.